Hi, in this video we are going to implement the Monte Carlo integration together, so let's get started. We are going to need include IO stream, and because we want to generate random numbers, we will need the standard lib stdlib.h, and of course we are going to use the namespace standard. We will have two methods, the double integrate from A to B with steps n. Of course, we will have the function we want to integrate, x, okay. We will have a main method. We would like to integrate from 0 to 1, 1000 steps and line. We will have the function and we would like to test it with the half of the quadratic function x times x, and we will have the integrate method from double a to double b int n. Okay, so here first of all I'm going to check whether the a is greater than b, and if it's true, then we return with the, we are going to call this method but with the right order, so b, a and n. Okay, else I'm going to have a double sum is initialized to null. I'm going to have a double x, and for int I is equal to 0, I'm going to rename it. It's not the steps, to be honest, it is the number of iteration. So we will have a million iteration with the iteration, of course. Okay, and for int I is equal to 0, I is less than the iterations I++. We just want to generate random numbers, random doubles. We will cast it, and we just have to call the rand method and have to normalize it to rand with the half of rand max. And we just have to sum up the f e a plus b minus a times x. Okay, so this is just the random sampling, and here we just have to sum is equal to the sum times the b minus a divided by the iterations. Okay, and we just have to return, of course, the sum. So let me test it, and that's why it's very important to have a random number generator and to be able to generate random numbers. And let me test whether it's working or not. We should get yeah, a third. Okay, and we can see that it's not converging very good. If you run it 100 times, it's not going to be very precise. As you can see, it's not very precise, but if we increment it, then it will be. And as I said earlier, in higher as you can see, it's much more precise if we double the number of iterations. So if we want to integrate whatever we prefer in higher dimensions, then it can be done with the help of Monte Carlo integration. So yeah, it's quite consistent, 0.3C3 plus the 10. Okay, so that's all about Monte Carlo integration. Thanks for watching.